Good morning, everybody. Today we're going to be looking at how to solve an absolute value inequality. So this is where we take the absolute value equations that we know how to solve, we take our inequalities that we know how to solve, and we push them together. And so we're going to just solve some basic equations that in inequalities that involve absolute values. So it's almost identical to solving a regular absolute value equation. So we know that the absolute value of x plus 3 is equal to 4 has two solutions. We know we take this equation, we're going to split it where we'd have x plus 3 equals positive 4 and x plus 3 equals negative 4. And we solve each one, so we'd subtract 3 on each side, and that leaves us with x equals 1. We subtract 3 on each side, and that leaves us with x equals negative 7. Okay, so that's really straightforward. But what happens if we come up across an equation that looks like this? The absolute value of x plus 3 is greater than 4. So what we're going to do is we're just going to take the equation. We're going to make sure our absolute value is the only thing on the left side of the inequality, and we're going to split it, same as what we did last time when we solved. So we're going to do x plus 3 is greater than 4. And when we split it, we've got x plus 3. We know we need to change that to negative 4. But what's going to happen is that's going to change signs. That's it. And then we solve the equation just like we've been doing. So we'd subtract 3. And we get x is greater than 1. We subtract 3 on each side. And we get x is less than negative 7. And then we just draw it on a number line. So we got 0 here in the middle. We've got 1. I know 1 needs to have an open circle, just like we did on inequalities, because it does not have a line underneath, and the arrow points to the right. On negative 7, so negative 1, negative 2, I'm going to skip a few. I'm going to get over to negative 6, negative 7, and at negative 7, I need to put another open circle, and this time our arrow points to the left. And voila, that's all we have to do. So just kind of moving on, we've got another example. We've got absolute value of x plus 3 is less than or equal to 4. So we're going to look at our equation. On the left side, the only thing we have is what's between the bar lines, so that's going to be good. We're going to take our equation, we're going to split it where we have x plus 3 less than or equal to 4, and then we flip the signs on everything on the right side. So x plus 3 is now greater than or equal to negative 4. And we solve each equation, so minus 3, and leaves us with x is less than or equal to 1. We minus 3 on both sides, and so that'll leave us with x is greater than or equal to negative 7. And we just put it on a number line, where we have 0 in the middle, we've got positive 1. I know since this has or equal to that I need a closed circle. The arrow is pointing to the left. When I come over to negative 7, I've got negative 1, negative 2, negative 3, so on and so forth, until I get out to negative 7. And at negative 7, I need a filled in circle because it's or equal to and a line going to the right. So this looks like one of those and statements that we did recently, where we have the two sections overlapping. When they overlap, it's going to tell us to write the interval. So we've got the overlapping section would be from negative 7 to positive 1, and we know if it's a filled-in circle, we put brackets. So that's only if the two intervals are overlapping that we do that. Okay, so we've got a couple more equations just to do a little bit of practice. So we've got absolute value of x minus 4 plus 15 is greater than 21. This one I see a problem because when I look at the left side, I have my absolute value, but I've got something outside the absolute value. I've got this 15. I need to get rid of the plus 15 before I can solve it. So I need to subtract 15 on each side. It's going to leave us with the absolute value of x minus 4 is greater than 6. At this point, we take our equation, we split it. We have x minus 4 is greater than positive 6, x minus 4, and now I flip the signs, less than negative 6. We just solve each one, so plus 4, That leaves us with x is greater than 10. The other side, we do plus 4, we have x is less than -2. Okay, we've got our answers. The only thing we have left to do is put it on a number line and be finished with this problem. So I'm going to put 0 in the middle. We've got -1, -2. -2, I know I need an open circle, and the arrow points to the left. When I get over to 10, so 1, 2, skip a few, I'm going to get out to 9, to 10. At 10, I have an open circle, and the arrow points to the right. And since this one doesn't overlap, I don't need to write an interval. That's going to be our finished equation. So example 3, we have 3 absolute value of x minus 7 is greater than or equal to 9. So we're going to divide each side by 3. And that leaves us with x minus 7 is greater than or equal to 3. And then we just solve it in the same way we've been doing. So we've got x minus 7 greater than or equal to positive 3. X minus 7 is less than or equal to -3. So we do plus 7 on each side. That'll give us x is greater than or equal to 10. Or x is less than or equal to 4. And we just put this one on a number line, same as the last problem. So I've got 0, 1, 2, 3, 4. At 4, I've got my filled in circle. It's going to the left, because I can see the arrowhead needs to point to the left. I'm going to skip over to 10, and at 10 I can see I need another closed-in circle, this one going to the right. And that's going to be our finished problem. It didn't have an overlap, so I do not have to write my interval. Okay, next problem, I've got this is going to be the last example. We've got absolute value of x plus 4 minus 10 is less than or equal to -2. So on the left side of the inequality, I see I've got this minus 10 that's not inside the absolute value, so I'm going to add 10 to both sides. That'll leave us absolute value of x plus 4 less than or equal to 8. Okay, since our absolute value is by itself, we're going to split the equation, where we have x plus 4 is less than or equal to positive 8. X plus 4 greater than or equal to -8. We solve each equation by subtracting 4. That leaves us x is less than or equal to 4, or x is greater than or equal to -12. Okay, so there's our solutions. All we have left to do is put it on our graph and call it a day. So I've got 0, I'm going to have 1, 2, 3, 4. And at 4, I can see I need a closed-in circle, and this one's going to the left. And then I've got -1, -2. I'm going to skip out to -11, -12. At -12, I can see, well, this needs to be a closed circle. And since the arrow is pointing to the right, it's going to be going like that. So I can see that it's overlapping from -12 to positive 4, so that's going to tell me I need to say the only solutions are -12 to 4. We had closed-in circles, so boom, we have to write that interval. And that's how to solve an absolute value inequality. Now, there are 2 special cases. I want you to just take a look at these, and that'll be it. So if we have the absolute value, so on this one, if I get absolute value of x plus 2 by itself, I'd have to subtract 3. So the absolute value of x plus 2 is greater than -3. Okay, now the definition of absolute value says whatever's between these bar lines, if we plug a number in for x, the answer from that has to be positive. So if I have a positive number, when is a positive number greater than -3? Well, that's going to be always. A positive number is always bigger than a negative. So in this case, this would be what we call, our solution would be all real numbers, because no matter what, it's going to be larger than the other side. And our number line, the whole thing's going to be colored in. Now, when we take a look at our other special case, we're going to subtract 10 on each side to start getting that absolute value by itself. We've got -2. Absolute value of x plus 4 is less than -10. Now, when we divide by -2, hold on, there's a typo on this problem, and I'm sorry about that. Let's pretend that -2 was never there. So we're just going to solve this. I'm sorry. We've got absolute value of x plus 4 plus 10 less than 0. So we've got absolute value of x plus 4 is less than -10. But this goes back to what we were saying earlier, that our answer from this is still going to be positive when we plug it in. If that's a positive number, when is a positive number smaller than -10? Or any negative? Never. So if you get your absolute value by itself, like I did here, then this is going to be a case where we have no solution. And that's going to be the end of that problem. Okay, so we're going to have a short assignment in class when we come in on this. The assignment is going to be the even problems from 2 through 26. Okay, I hope you have a wonderful day, and I'll see you all next time.